This animation shows how the internal shear and moment vary along the length of a uniformly loaded beam, with the shear being greatest at the ends and the moment being greatest at midspan.
According to the governing differential equation for the deflection of the beams, the first, second, third and the fourth derivatives of the function are corresponding to the rotation, bending moment, shear force and the uniformly distributed load, respectively. By using Taylor series, we can obtain Maclaurin expansion series as shown in equation 6. By substituting differential equation of rotation, bending moment, shear force and the uniformly distributed load into equation 6, we can get the equation in equation 8. Here comes an example on how are we going to apply Taylor series in calculating the deflection of beam. This figure shows a simply supported beam under a distributed load. For simply supported beam, we have the boundary condition as shown above. Hence, the Taylor series expansion for the deflection of beam can be expressed. For a simply supported beam condition which there is a point load applied at the center of the beam, we can assume that Q'0 and Q'0 and others are equal to 0. Hence, the equation will be reduced as shown above. Here comes example 2 after the derivation of equation using the example 1 which uniform load applied on a beam. Example 2 shows a point load is being applied at the center of the beam. By using equilibrium equation, we can calculate that shear force at the pin is equal to force P divided by 2. By differentiate equation 10 with respect to x, the rotation of the beam can be determined as in equation 11. As we know that the rotation at the center of beam is equal to 0. Hence, we can conclude the equation for calculating rotation using equation 12. Substituting the value of shear force and rotation equation into equation 10, equation of the elastic curve of the beam and the maximum deflection are determined. By using equation 13, substitute the given parameters into the equation. Hence, we can directly calculate for the deflection of beam. That is all from us. Thank you for watching.